Today's lesson, today we will be looking at electricity. What is electricity? Okay, electricity can be defined as a form of what? Energy. Okay, how is electricity formed? We are going to take the origin from atom. Remember, we talk about the atom. Now you need to know that the atom contains three important particles, which are the electron, the proton, the neutron. Okay, the electron is negatively charged, while the proton is positively charged, and the neutron does not have any charge. Generally, the plus and minus will attract each other. So a proton will attract an electron, and the minus and minus will repel each other. That is, an electron will push another electron away, and a proton will also push each other away. Now, when two atoms are coming together, if one of the atoms has enough electron, okay, and the other one does not have enough electron, because the first atom has enough electron, some of the electron will move from the atom that has enough electron to the one that does not have what? Enough electron. This movement of electron from the atom that has enough electron to the one that does not have enough electron is what results in the formation of what we call what? Electricity. So electricity is formed when an atom has enough electron to give out. Okay, as the electron move, they generate what we call the what? Electricity. So here's a clear explanation of what I'm saying. You can see the minus moving, is it not? Yes, this movement generates what? Electricity. Another way we can do this, we can experiment this using an ebonite rod. Okay, imagine that I set up a practical as shown. This ebonite rod, I rub it with what? A glass, and then I tie it to a rope, and then I get another ebonite rod. I also rub that same ebonite rod with what? A glass. When I push it to it, it will push the other ebonite rod away. Why? Because both of them are negatively what? Charged. Now, if I take the same ebonite rod and decide to rub it on a paper, as you can see, so when I rub it on this paper and I push it to the ebonite rod, it will attract. Okay, so we say plus and minus, they do what? Attract each other. In this case, we can call the ebonite rod and the ebonite rod negative, but the ebonite rod that is charged with the paper positive. Okay, so when the positive and the negative meet together, they do what? Attract. When the negative and negative meet together, they do what? Repel. Likewise, when the positive and positive meet together, they also do what? Repel each other. So like charge repel, unlike charge attract. Like charge repel, unlike charge attract. Plus and minus, what do you think will happen? Okay, I have a plus and a minus, a positive and a negative, they will what? Attract. Alright, they will attract each other. I have a minus, minus, what do you think will happen? A minus, minus, they will do what? They will what? Repel each other, they will push each other away. And then I have a plus, plus, what do you think will happen? Alright, they will also do what? Push each other away. Except a plus, there are two main types of electricity. One is called static, and the other is called current or current electricity. If you pick up a comb and comb your hair, and take that comb to attract some small piece of paper, it will be attracted to those paper. Why? Because you create a charge by doing that on the comb. This type of charge that you created is called static electricity. Okay, the electrons are attracted. The scientist that brought about this is called Thales. He discovered that when you use an amber to rub a piece of paper and touch it on a feather, the amber attracted the feather. So that generated what we call what? Static electricity. Okay, another real life experience of static electricity is what you're seeing in the lightning. Okay, the lightning you're seeing is an example of static electricity, because electricity is generated when icy materials what? Collide in outer space, and then these electrons accumulate and then they discharge itself between the earth and the ground. This is the reason why you see most buildings are protected with a rod at the top down to the earth, so that when this kind of current comes to a building, it will be attracted by the metal, which will send it down to the ground instead of destroying the what? The building. So static electricity is an electricity that is generated in one position. Okay, the other type of electricity you want to look at is the one that powers your home, when you used to read at night, the one you used to watch television, and then just other forms of what? Electricity that you use daily. How does it come? It moves through lines, or what we call what? Wire. Okay, and it is called current electricity. What do you call it? Current electricity. So current electricity is seen in different materials and different places. Current electricity is now further divided into two types. Although you already know that positive and negative do what? Attract. Is it not? Why negative and negative repair, and negative and positive will also do what? Attract. Positive will what? Repair. So when current flows in one direction from a negative terminal through the positive terminal, it is called a direct current. But if the current flows through and fro, forward and backward continuously, it is called an alternating current. I want you to watch this video and learn more about alternating current and direct current.
Alternating current, which we often write as AC, and direct current, or DC. In an alternating current, the direction of the current is constantly swapping back and forth. So the charge flows in one direction, then the other direction, and back again. We get these alternating currents whenever we use an alternating potential difference, or alternating voltage. So one that fluctuates between positive and negative. And back again 50 times every second. And so the current would also fluctuate at that same rate. One thing we should mention is that you'll sometimes hear that the voltage is 230 volts rather than 240. Basically, it can be either in the UK, so they're both correct as far as your exams are concerned. Direct current, on the other hand, is produced by a direct potential difference, which is either positive or negative the entire time. So the charge is always flowing in the same direction. We find direct current in things like cells and batteries, like those in your phone or a calculator. The last thing we need to cover is that in order to get these potential difference versus time graphs, we use devices called oscilloscopes, which display the graphs on a monitor.
Welcome back from that video. I believe with this lesson you now know what electricity is. You now know the two types of electricity. You know how electricity is generated, and you also know the two types of current electricity, okay? That now brings us to the end of today's lesson. I want you to do your other activities in this lesson and stay safe. I'll see you soon. that now brings us to the end of the lesson. I want you to do your assignment and stay safe.